The central processing unit, commonly referred to as the CPU, is often described as the brain of a computer. It is the core component responsible for processing instructions and performing calculations, enabling a computer to carry out tasks ranging from simple operations like word processing to complex simulations and data analysis. Every operation a computer performs relies on the CPU's ability to process and manage the flow of data and instructions within the system. The CPU works by executing a sequence of instructions provided by a program. These instructions are written in machine code, a series of binary commands that the CPU can interpret and process. At its core, the CPU is designed to carry out three primary functions: to fetch instructions from memory, decode them to understand what action is required, and then execute the action. This systematic approach is known as the fetch, decode, execute cycle, which underpins all CPU operations. The fetch stage begins with the CPU retrieving an instruction from the computer's memory, specifically from the random access memory, RAM. The memory address of the next instruction to be executed is stored in a special register called the program counter, PC. The CPU uses the address in the program counter to locate the instruction and fetch it into a register called the instruction register, IR. Simultaneously, the program counter is updated to point to the address of the next instruction in the sequence, ensuring a continuous flow of operations. In the decode stage, the CPU interprets the fetched instruction to determine what needs to be done. This is managed by the control unit, a key component of the CPU responsible for directing operations. The control unit analyzes the instruction in the instruction register, breaking it down into its constituent parts. This process involves identifying the operation to be performed and the data or addresses involved. For example, the instruction might indicate a mathematical operation, a data transfer, or a decision-making process based on specific conditions. Once the instruction has been decoded, the CPU moves to the execute stage. During this phase, the appropriate components within the CPU, such as the arithmetic logic unit, ALU, carry out the required operation. The ALU is responsible for performing mathematical calculations, logical comparisons, and other fundamental operations. If the instruction involves moving data, the CPU will transfer it to or from memory or another register. The results of the execution are then either stored back in memory, outputted to an external device, or used to influence subsequent instructions. The fetch, decode, execute cycle is repeated continuously at incredible speeds, often measured in billions of cycles per second, known as gigahertz, GHz. The speed and efficiency of a CPU depend on several factors, including its clock speed, the number of cores, and the architecture of the processor. Multi-core CPUs, for instance, can handle multiple instructions simultaneously, significantly enhancing performance in multitasking or processing-intensive applications. In essence, the CPU is the powerhouse of a computer, tirelessly performing the fetch, decode, execute cycle to process instructions and manage the flow of data. Its ability to perform these operations with speed and precision is what allows computers to function as versatile tools in countless applications. As technology evolves, CPUs continue to become faster and more efficient, driving advancements in computing and enabling new possibilities in the digital world.